Alright, welcome to Random Stuff Episode 9. This is going to be a very short and specific episode. We will create the ultimate version of our hex displays. I'm talking about these little 8 and 16-bit hex displays that show 8 or 16-bit values, and this is useful for debugging digital circuits. You may recall in some previous Random Stuff episodes, we created these slightly better versions of our hex displays, and in this video, we will come up with the ultimate version, and really the only thing that's new is that these will use the blue 7-segment displays that I got from lcsc.com. They are smaller, they are brighter. Basically, this completely satisfies all of my requirements for hex displays. All right, let's get started. Let's start by talking about the new PCB designs. The process of changing the design to accommodate the smaller 0.2-inch wide blue LED displays was fairly straightforward. I modified the schematic to add two 1x5 pin headers for each display, in addition to the standard 10-pin dip socket from the original PCB designs. I then exported the revised netlist, deleted the original dip socket footprint from the PCB, and re-imported the netlist, preserving only the 1x5 pin headers and moving them into the correct positions on the PCBs. At this point, it was a fairly straightforward process to modify the board outline, move the switching transistors, and route connections for all of the display pins. The new PCB designs are electrically identical to the original designs. The only significant difference is the footprints for the segment displays. Once I had completed the new PCB designs, I sent them off for fabrication. I ordered blue solder mask, which seemed appropriate given that the segment displays are blue. As before, soldering the surface mount components was challenging. I took the advice of viewer Viva Verm and used significantly more flux this time. Based on a review of flux from a video by SGG Electronics, which I will link in the video description, I ordered some flux paste from Banggood and liberally applied it to both pads and component legs prior to soldering. The resistors and capacitor were easy to solder using the method of placing a solder blob on one pad, melting the blob and placing the component using tweezers, and then soldering the other side. This technique also worked fairly well for the SOT23 package transistors. The microcontrollers were more challenging. The SOIC20 package of the ATtiny 2313A on the 8-bit display was pretty easy to solder since it uses a relatively generous 1.27mm pitch. The TQFP44 package of the ATmega 164A used on the 16-bit display was significantly more challenging. What I found worked best was working on the pins one at a time using a fine soldering iron tip, heating the pad and pin, and flowing a very small amount of solder onto the pad using thin 0.5mm solder. However, it was still quite challenging to make the solder flow where I wanted it without creating solder bridges. I think that one way in which I made my job unnecessarily difficult was not choosing footprints with long pads, such that the pad would extend significantly beyond the leg of the component. I think that this would have made it easier to flow the solder from the pad toward the component leg. If I decide to spin another revision of these PCBs, I will see if I can use footprints that are more conducive to hand soldering. Alright, so I think we're ready to test here, and my little test circuit is set up basically so that I can flip these dip switches to create various patterns on these 8 wires. Basically, I'm just going to test the 8-bit version right now, and essentially what I want to see is that all of the different digits are displayed correctly. And one thing I'll point out here is that you can read this really well on camera. I have really, really bright lights shining on this right now, so these displays are really bright. Okay, so I'm going to test all the digits. I will speed this up because I don't think it would be very interesting for you to see me do this in real time. Alright, so that worked quite well. Let's try the 16-bit display. Okay, same drill, this time with a 16-bit display. These digits correspond to pins that are not connected right now, so they're pulled up by some pull-up resistors. Alright, so let's make sure we can display all the different values. Okay, so now I'm going to test the lower digits. All right, I think it works. Alright, so in conclusion, these displays work. I'm very happy with them. The visibility and contrast is excellent on camera, so you will probably be seeing these in some future videos. And one thing I am leaving as kind of a note to myself is that for any future projects where I'm going to be assembling boards that have surface mount components, I'm going to try to find footprints that are better for hand assembly. There are a few videos that should be coming soon. I have some additional PCBs for modules for the 6809 system, so I will assemble and test those. I'm going to continue working on the FPGA display processor. Also, my PC motherboard died recently, and I have some ideas for how I can cope better with that eventuality in the future. Alright, I will see you in the next video.